Okay, alright, let's start. Okay, so we have come to the final segment of chapter 4, right? So previously we have been talking a lot about forces, finding the resultant force, what happens when the object is in equilibrium. We have been talking about Newton's law of motion, right? Finding the acceleration, right, of a moving object. Okay, and then now we have come to friction, which is the force that opposes motion, right? So you can see the picture. Okay, friction can be used to generate what? Generate heat, right? Generate that fire, okay, between the dry wood and the dry hay, right? Okay. Right, so what is friction, right? Friction is the contact force that opposes or tend to oppose motion between surfaces in contact. Right, so the key thing is that for friction to take effect, right? Okay, the object must be in contact. Okay, so for example like that, right? Okay, the surface is rubbing against one another. Okay, and the key point is that friction is present in our daily life and affect how objects move, okay, in our daily life, right? For example, when you're walking, right, you need friction, right? If you walk without friction, what will it be like? Right, it will be like walking on ice, right? It will be slippery, right? You cannot walk properly. Okay. The causes of friction you can add into your notes. Okay, number one, surface roughness. Okay, so rough surfaces will create more friction. Okay, which is true, right? You ask yourself, right? Compare the same floor, right? Okay, the same flooring. Okay, you compare a sunny day and a rainy day. Okay, which one will which day, right, will cause you to slip and fall easily? Okay, the one with the, okay, it will be the rainy day, right? Because when you have a rainy day, the rain, right, causes the same flooring to be smoother, right? It causes the same flooring to be smoother, and therefore there is less friction. Secondly, material interaction. Okay, so this means that different materials have different friction level. For example, you compare aluminium foil versus a piece of cloth, right? Which one have a larger friction? Okay, you compare rubber, okay, with wood. Okay, means that when you slide them across, right, which one have more friction? Okay, so material interaction. Okay, there's a type of friction, there is two. Okay, so that is important. We are very we will commonly know friction as kinetic friction, right? The one that oppose the moving object, right? So the object is already moving, and then you have friction that is acting against the object. Okay, but static friction might be new to us. Okay, so static friction, right, is the friction that resists an applied force, right, on an object that is at rest. Okay, so what do I mean, right? Is that let me see what can I. Okay, so let's say this one is my phone. Alright, so this is my phone. Okay, I am going to place it on my hand. So you take the hand as my surface. Okay, the hand is my surface. Okay, the phone is on top. Okay, and then what I'm going to do is I'm going to push. I'm pushing already. I'm pushing already, but the thing is that the object is still not moving. Okay, and that's because, right, the force, there is a static friction that's acting, okay, when I'm pushing. Okay, when I'm pushing, there is a static friction that's acting on the object, and my force, right, is less than the static friction. That's why the object is not moving. So I will increase my force. I'll increase my force until the force exceeds, I repeat, until the force exceeds the static friction, then it will start to move. Okay, right, so originally not moving. Okay, I exert a force, also not moving. Okay, that's because the force is less than the static friction. I increase my force until the force exceeds the static friction, and then the object will start moving. Okay, right. Okay, so friction in action. Okay, so we talked about this just now, right? When you are walking, when the car tire, you are braking, right? So the thing is this, is that actually when you are walking forward, friction acts forward also. it sounds counterintuitive, right? Because we always know friction as opposing motion, right? So in the sense that if we are walking forward, then actually friction should be backwards lah. But the thing is that when we are walking forward, right, our foot is pushing in the backwards direction. And since our foot is pushed in the backward direction, friction acts forward. Okay, same thing for your car also, because the car is moving, the car, right, is moving in a certain direction, right, in a circular direction. So let's say for example in this slide, right, on your right side, the car is moving in clockwise, right? So when the tire right is hitting, when the tire is in contact with the floor, right, the tire is actually backwards, right? When the tire is in contact with the floor, the tire is actually backwards, and then friction will, in the opposite direction, right, then friction will go forward. Okay, right, but the car is moving forward, right? So this is some of the interesting cases of friction, right? Okay, so then how do we reduce friction, right? Because there are some times where we want to reduce friction, right? Because friction may cause wear and tear, for example, in your machineries. Okay, so you have lubricants. So lubricant help to reduce friction by creating a thin surface layer between surfaces. Okay, so that the moving surface do not directly rub against each other. So for example, in your bicycle, your gear and chain, right, you always put your oil lubricant. Okay, in machineries as well. Other alternative methods will be ball bearing, okay, between moving parts in the machineries, okay, as well as use highly polished surface, right, between moving parts. So highly polished surface implies what? Is the surface rough or smooth? Smooth, right? Okay, object falling with resistance, right, I'll record another video, okay?